All right, here we're doing Maclaurin series, and Maclaurin series is an approximation of any relatively nice function. So we want to do the fourth order, which means that we're going to go up to the x to the fourth power. I'll just do the first one as an example here. It's really a very similar process for any of these sort of problems where you're constructing it. So start with f of 0, because Maclaurin means to plug in 0. So if I plug in 0, I get 0 e to the 0, which is 0. Now let's calculate the derivative. The first derivative is going to be a product rule example. So we just have 1 e to the x plus x e to the x, which it's a good idea because we have to go to the fourth order here. We have to take several more derivatives. It's a good idea to try to simplify. So it becomes e to the x times 1 plus x. That's f prime of x. I could do f prime of 0 while we're at it. F prime of 0 is going to be e to the 0 times 1 plus 0, which comes out to be 1. Okay, let's do f double prime. F double prime of x, we're going to do a product rule again. E to the x times 1 plus x plus e to the x times 1. Let's simplify. Both terms have an e to the x in common, and it's 1 plus x plus another 1, so we have 2 plus x. I'm noticing a nice pattern here. And if I plug in 0, so if we do f double prime of 0, we get e to the 0 times 2 plus 0, which is 2. It'll be really nice if our third derivative pops out to just be 3. So let's do it. Let's do our third derivative. E to the x, that's f prime times g, 2 plus x, plus f times g prime, which again is 1. Yep, same sort of thing happens here. Both terms have an e to the x in common. Now we have 3 plus x of them. So that's f triple prime. Sometimes you'll see just a little number like a 3 there because it gets annoying to count the apostrophes. And that would mean f triple prime of 0 is going to be 3. And I could write it out, but I am convinced that f quadruple prime of 0 will be 4. And so now what we can do is that's really nice. We have 0, 1, 2, 3, 4. So we can write the Maclaurin series. And so what I'm going to do is switch over to the Desmos tab because it wants us to confirm our answer graphically. So let's open up Desmos here. Let's see. So we had 0, 1, 2, 3, 4, and our original function is x e to the x. Okay, so here's x e to the x. It's a good looking function there. And then we have our Maclaurin series. And so our Maclaurin series is the idea that your function is equal to f of 0, which was 0. And that's really all you need to do. But for the sake of showing the general form, I'll type it in like this. So it's the f of 0, x to the 0 over 0 factorial. Of course, you didn't even need to type anything because that's all just 0. Then f prime was 1. It's the first derivative, so I go x to the first power, and I divide by 1 factorial. Of course, writing the first power, writing 1 factorial, all that's a little bit redundant. If you look at the graph, you will notice that this is a approximation of the function for a very small interval. So then if I go back and add on the next term, we had plus 2x to the second, because it's the second derivative, divided by 2 factorial. And if you notice, the little circle that I drew got a little bit bigger. It got a little bit better. The approximation improved. So now we go to 3x to the third power over 3 factorial. Now, if I wanted to draw just visually an approximation region, I mean, it's pretty good in there. So we're getting better. And the question asked us to get all the way to the fourth degree. So we have plus 4x to the fourth divided by 4 factorial. And check it out. It's looking really good. And I hope you can see how by adding on more and more terms, we can increase the interval of convergence. And that's the whole idea. If we had an infinite number of terms, we could approximate it to any given amount that we want. So that's the basic idea with Maclaurin series. Feel free to ask if there are more that you want examples on. In the second video, I will show you how you can kind of shortcut things because you don't always need to compute and construct the Maclaurin series from scratch. You can use an existing Maclaurin series and substitute. So that's the next video.